an informative session by Royal Saber. I'll be your host and speaker for today's webinar. We will go through this webinar as per the agenda, and in between, if you have any queries, feel free to post to us on the chat window. There will be a dedicated slot for Q&A at the end of the session. You, you can also write to us your queries to this email ID, namely info@roysaber.com. We'll be sharing our webinar survey form at the end of the webinar. Please do fill in and revert back to us. In case if you have any trouble listening audio, text to us on the chat window. Let's get into the webinar. Today's topic is about IBM Dependency-Based Build for mainframe development or modern development environment. I'll be speaker for today's webinar. Myself, Vijayalakshmi, manages mainframe practice at Royal Saber and helps our customer on modernization and migration engagements. Here is our quick agenda for today's session. So we'll have quick glance about Royal Saber and our mainframe practice, our internal assessment solution, and of course the topic is about IBM DBB. Regarding Royal Saber is a fast growing IT consulting and digital transformation company specializing in IT services and solutions. We have more than 2 decades of experience, almost 2000 plus consultant across the globe, and we headquarters with Naperville, Illinois, USA, and we have global presence, Canada, UK, Australia, New Zealand, Middle East, Mexico, South Africa, etc. And we have multiple offshore development centers in India. We have strategic partners with a lot of technology company like IBM, Microsoft, Amazon, Google, Heirlooms, Broadcom, and others, which eventually helps our customer on digital transformation journey. Our practice is actually under our mainframe practice. We provide reliable and high performance solution and services for our customers. Uh, Under mainframe infrastructure management, we provide ZOS, ZVM, and ZLinux and other ISV product install upgrades and infrastructure engagement activities. Under mainframe services, we do application support, 24/7 production and application enhancement supports. Mainframe modernization vertical, where we do mainframe integrations with the front end and middleware tools, and mainframe related modernization and migration engagements. Managed services, under which we our infrastructure support and application support, and we do take care of modernization training initiatives. Our assets and solutions, we internally build our mainframe related assets, which will support for our customer engagements, which will help to expedite our services. So the recent asset what we developed is a legacy SCM modernization, which is an SCM migration tool, which eventually migrates application assets from CA Endeavor to distributed modern SCMs like Git, GitHub, GitLab, etc. And it's an automated migration utility which migrates the complete application into your latest modern SCM tool. We also developed a similar migration with Endeavor to RTCZ in earlier, like 2015, where our customers were using RTCZ. And we do have our integration plugins which supports CA Endeavor to uh, Urban Code Deploy. So Urban Code Deploy is IBM tool and CA Endeavor is from CA. So we do not have direct plugin. Our custom application can able to integrate both, and it will support for automated deployment with UCD. We also developed some migration tool for Micro Focus to COBOL, and we build our own custom code review tool for one of the customer requirements, wherein domain specific rules will be developed with our Java code and we deployed in IDZ. And we have some web application which is going to do password reset, and web application which is going to monitor our middleware tools like MQIAB, which runs on Z server, which we can monitor through your desktop, and we can proactively do some kind of an uh, initiatives. And it we also support for Z DevOps solutioning. So this shows our strong capabilities on mainframe practice, and given an opportunity, we will try to provide the custom solutions. So today's topic is about IBM dependency-based build. Let us get into deep dive into this topic. So very brief introduction about IBM dependency-based build. So IBM dependency-based build is basically a modern build tool which helps for modern development, mainframe modern development initiatives. So it is basically helps you to build a traditional 0s application which is written on COBOL, PL bar 1 or assembler. So it's a scripting tool. It's a script based tool which is written on Java. We call it Groovy Script, and it's a standalone tool. In fact, it does not require any SCM or the automation pipeline automation tool. So it's a standalone product which helps you to support for modern build environment. So its primary purpose is to compile, link, edit your 0s application. As a mainframe developer or mainframe SMEs, you know your applications need to be compiled uh, and link edited so that it is converted into executable version. So in legacy environment, we normally have a JCS which does your compile, link edit, and other intermediate process. So wherein for a modern mainframe development, we have this IBM dependency based build, which is a script based tool. It's called as a Groovy Script, so which helps us to do the build or compiling of your mainframe application. So eventually, how this IBM DBB supports in your modern development environment. So this is a quick glance of how the modern development environment will look like. So in a modern environment, of course, your application relies completely on legacy system Z server. Your mainframe legacy application resides on your mainframe, and it also supports your modern environment like IDZ, IBM Developer for Z, which is an developer tool, Eclipse based IDE, which helps for modern development in place of ISPF code change. So the developer can use this. So this can be installed and configured with your mainframe with the help of small starter task called RSED starter task. Okay, it's an additional component which is enabled to make this developer tool. So when a developer does the code change in IDZ, the code can be stored. That is, version controlling happens with your GitLab or Git or any of a modern tool. So in this case, it is GitHub. So which is a code station or code repository, source control tool or software configuration management tool. So this helps to connect. This is a Git server. It helps you to connect with your Git, which is an Rocket Git, which runs as an agent on mainframe operating system. This also helps for the planning, and it also supports your pipeline automation. And so now our focus is on IBM DBB, which is an it's a toolkit which you can install on your mainframe operating system under your OMBS region, and which in turn has an web application which basically helps as an interface to look at the dependency build results and the build histories. So this DBB which helps us to scan your application for any changes do the impact analysis, and it helps to compile, link it, and produce the build report. So the build report can be viewable in your web application. So this is need to be separately installed and configured to make use of your dependency based build. So there are two options with which the product can be installed and configured. And once it is installed, the prerequisite for this modern build environment is these need to be installed and configured and ready to use. And as it is a modern environment, the automated deployment happens with UCD, and UCD comes with your UCD agent running on your Z system, and your server is from the distributed. So all these component, your IDZ, UCD, DBB web application, and your Git server runs on your distributed environment, whereas and these components or the kind of agents which is installed and running on your ZOS operating system. So this is how your typical modern environment looks like. And let us now focus on how is our dependency based build is set up, and how this modern build will be triggered with this. So the typically your the modern build, who are the users in the sense the mainframe developers or maybe the build engineers will make use of your IBM dependency based build. So as we have seen, this is an script based tool. Your scripting language is in the form of a Groovy, and typically like how this entire process will be driven through. Any code change happens, then the build is triggered through your continuous integration tool called Jenkins. So Jenkins server, from where the build request is triggered, and this takes the request your Jenkins slave, the agent running on your Z system, Z Zenkin, which can able to sense this request. And for whatever the change request is requested, the Jenkins is going to make the pull request to your Z get, which is Rocket get. And this is going to invoke your required source code from your uh, Git repository. And whatever the source code which is taken, you have a Groovy script to do the compilation, so which is basically from your IBM dependency based build, which provides your Java based API to do complete compilation in the form of your Groovy script. And this basically happens to be in the form, it keeps everything in the dataset format, PDS format, and your build results will be viewed or verified through your web application. So a web application creates a complete log of whatever the application is compiled, built, and everything. And your DBB toolkit, which is running on your ZOS OMVS region, which I mentioned earlier, which is nothing but your Unix system services. So this is how typically the components will closely interact each other. Uh, this is little more focused towards your build stage. Now, how this Groovy is going to support us for our compilation? The primary responsibility of your DBB is to build your application, or which is nothing but your compile or link edit. So how it is going to support our compile and link edit? Just you can recall your compilation part of it. So the compilation is in the form of a JCL, or in other words, job. So this your modern build suppose some kind of a Java classes to uh, define those jobs as equivalent to that of your JCLs in the form of a Java classes. So you have a Java classes called MVS exec, which is nothing but whenever you wanted to invoke your program, probably you will need to make use of this class. Or you wanted to execute some TSO commands, you can call your class called TSO exec. And same way ISPF, from where you wanted to execute ISPF exec. Your JCL exec is nothing but your JCL steps. And in between the steps, you may need to create some data set or delete data set or copy some content from one data set to other. You have one classes like create PDS, copy to PDS, copy to HFS. And so these are all the Java classes supplied by your IBM as IBM DBB APIs. So which we will make use to create your Groovy script, which helps for building your ZOS application. So little brief about how this classes and what are the different methods. So when you say Java classes, as you know, Java classes comes out with your various properties and methods. So when you wanted to create a new data set, so your create PDS class is invoked. So you are making an instance of this class with the new. And so once you create an instance, you have some kind of an property setter methods. In other words, I can say a setter methods, set data set option. So to set value to this instance, which means your dataset name is assigned with the set dataset, and dataset attributes are assigned through set options. And to create a dataset, you invoke a method called execute. So instance that new PDS dot execute is eventually creates your new dataset as per this attribute and the name given here. So like this, your classes comes out with various properties and methods, and you do have a get a method and set a method to set something or get some values from your class. So this is for creating a PDS. The same way you can copy a content from one PDS to other. So here it is copy to PDS. It's copying a content from HFS file system to PDS. As I told, DBB is running on mainframe OMVS or Unix operating system. So here it is in the form of hierarchical file system. When I wanted to compile or when I wanted to build, this need to be copied in the partition data set. So all my Groovy script will have this step as a mandate because I wanted to copy the source file from hierarchical file system to partition data set. So I'm calling this, and same way I'm using it is self-explanatory. I'm using some setter and methods and execute command to make the copy happen. And the same way as goes with a delete, you have an data set name with some kind of a classes defined here. To delete a data set, we all know IEFBR 14. So this program you can invoke with MVS exec class. So this is how it is, MVS exec dot class dot method, and you're invoking this to delete a PDS, and you are going to assign various setup method to assign the respective value for which data set you wanted to delete. And the same way it goes for a syslib concatenation, which helps you to create your syslib concatenation data sets. So in the form of a Groovy script, whenever you're calling a program, you will have syslib. You're creating a dataset name with this DD statements, and then probably you will have syslib concatenation uh, of your DD name, so which will create your concatenation of syslibs. So these are all a little bit we need to understand so that we can do the custom changes on the Groovy scripts, whatever is required for our application specific requirement. So MVS exec, it's basically to invoke your program, such as your compilers, link editors, or pre-compiler. So whatever this JCL procedural step, exec statement, whatever we will invoke, where we will make use of MVS exec. And again, you have some methods to execute this and assign the values with the help of our properties. And MVS job. So on the whole, when you wanted to execute the job, we'll use our TSO command submit to execute the job. So here you have a MVS job class and class dot start and stop method to start and stop your methods. So hopefully this would have given little brief and fair understanding about how your Groovy script or DBB build is structured to compile your legacy application, right? So now let us get into how what conceptual basis it is going to develop your build. So here DBB tracks the build with the help of the dependencies. So it does dependencies in the form of full build, and also it can also do the build in the form of an incremental build. So whenever I wanted to build the complete application, whatsoever is changed, my application consists of a number of programs, out of which set of 4 programs is undergone the change request. Then I can go for compiling a whole build, which means the entire application will get rebuilt. The changes will get compiled, and the rest of the application will rebuild the full build. Or incremental, since last change, whatever is the since last build, whatever is the recent change, only those change set will get built with an incremental build. So it suppose for both, and to perform this or to perform this kind of a build, it keeps 3 different types. So you have a direct build dependencies. There are 3 types of dependencies which helps for building your ZOS application: direct build dependencies, indirect build dependencies, and Z unit test dependencies. So direct build dependencies meaning whenever you have a ZOS application, so you will often references an application program PGM1 will refer to other source files in your program, right? So maybe it may reference a copybook, it may reference and include statements, include libraries. So all these are called as a direct. The program is referencing an other sources of copylib or includes or any other precompiler related directives it may refer. So those called as a direct build dependencies. So to perform that, we have a separate type called direct build, and it has a separate scanner also. And indirect build dependencies is nothing but when you have a program, that program may refer to the some other file which has incorporated some change. So for example, program A may refer some of the copybooks which is getting changed or by other application changes. So those things. So any kind of an the changes which happen because of the code change, you are eventually that it is impacting your other programs. So it is nothing but your impact or impact analysis also, which will identify the programs that was impacted by some little bit of code change. So which need to be compiled. So which is indirect build dependencies. And Z unit build dependencies is nothing but your Z automated testing. So whenever we talk about a modern development, which is an pipeline is built to, when you do build, it need to be unit tested with an automated test case. So for mainframe applications, you have a Z unit testing framework, which does an automated unit testing of your application. So when you invoke your a CI or CD pipeline, so which eventually your DBB also triggers your test cases as a part of your CI CD pipeline jobs. So here your Z unit test configuration dependency scanner, which is something is configured here, which helps you to automatically create your relationship between your zero source program to the test program and the playback data file. So the test program playback data file or the part of Z unit test, and zero source program is your application code. So when I wanted to unit test, I need to incorporate my test program and the playback data file to do the automated testing. So Z unit test build dependency does it get invoked for during your automated testing phase. So you have 3 types of a dependency builds. How do we handle this dependency build? As we discussed what are the different three types. Each will internally invoke the scanners. Your direct build dependencies will invoke a dependency scanner. Your indirect build dependencies will invoke either dependency or the linked. So here indirect build is either through the generated copybook. So meaning, let's say for example, my COBOL DB2 CICS application I'm compiling. My CICS applications has an map, BMS map. So your BMS map is kind of an macro which is returned when you compile. It will generate a copybook, correct? That is a generated copybook. So which in turn is referenced by your program. So that is actually called as an generated copybook. So which when your source program is referencing, that time it will invoke a dependency scanner. And there is another type of indirect dependency which happens through link dependency. So meaning when your program is linking to your and another program. Say for example, I have a program A which links to program B. I've written a COBOL program A with a link. Okay, a link program to B or maybe CICS program to link program to B. Either way, COBOL or DB2. COBOL with call statement and CICS with exit CICS link program. So in this case, it will be kind of a link dependencies. It may be either static or dynamic link. So those is called as a link time dependencies. So which is can be scanned by linked scanner. So these are the three types of dependencies wherein we have these three scanners defined, which will take care of scanning our build process. And here is our glance of a sample Ruby script. As I briefed, it's just you're going to recall your compilation JCL as equivalent to your Groovy script you're going to prepare in DBB. So as DBB is and written in Java and it has got a Java API, Java classes, it is we have to obviously import those packages to make use of the classes and methods and procedures, right? So we are invoking the package by import statement. So this is your package name where all your DBB build related classes and it's supplied here. And this is nothing but your set parameter what we use in our compile JCLs to assign uh, the global level variable value to the variables. And say we may need to create some data set prior to your compilation. So we are going to make use of a create PDS class and methods to create the required data set, which is it may be sometimes your permanent data set or sometimes temporary data set we may need to create for a compilation. So that happens with this. And yeah, as we discussed, MVS exec is going to invoke your compiler. So this is a sample for COBOL compiler. IGYCRTCL is my compiler, which I'm invoking. While invoking, I'm also passing in compiler parameter or compiler option called lib. So it's normally POM parameter we will use. The same thing you're using as an uh, kind of a setup method. So I'm calling this program dot POM. It is invoked via lib statement. So lib parameter, sorry. So this is your compilation step, which is nothing but your JCL procedures. And here, this is how it will look like. And you, once after your JCL step, you can see some concatenation. So before you concatenate, you will write your sysin DD statement. So your DD statement is prepared like this. Your sysin DD statement of sysin. Sysin data DD statement is prepared like this. And if you have any concatenation, you will have something called concatenation also can happen. And eventually when you wanted to execute, you will call the execute method. And normally we will use the maxc parameter to check our written code in mainframe legacy system, since it is a Java program. Of course, there also we have an RC. Written code is called as an RC. MaxCC or RC we will check. So as it is an written code, we are checking here in this with this, and accordingly we are proceeding our responses to your the build results. So there we will looking at the spoofy. Here you can look in the console window of your modern IDE, as well as it can be written onto your log. So this is how this Groovy script looks like. And when I wanted to build the application with the help of DBB, with whatever this discussions we have made, so we come across various different types of scanners and different approaches like direct or indirect and so on. So in general, how do I invoke? What is a command which is required to invoke my Groovy script? So this is basically a kind of a JCL, how it looks like completely. When I wanted to trigger this DBB script, your script basically has like this, your Groovy. It's actually an kind of a script which is available in your bin folder, bin directory. And to invoke this, it typically requires 4 arguments or 4 parameters. So I'm invoking my script from your bin directory, and it has got 4 arguments. So one is you're going to talk about your workspace uh, location where your source programs are kept, your repository for your source program. So this is basically your whatever the application you pulled from your local git. It will be here in your workspace, and you have to give your application name as your second parameter. So application name, this is nothing but your directory name in your uh, this setup. And output, the build results need to be kept somewhere. So the build directory where your output can be kept, and your HLQ, your build dataset, build partition dataset where you can keep your build results. High level qualifier is specified. So this is how the 4 parameter is going to take. Your build script process will understand where is your source code, what application you're going to build, and where is your output need to be stored, and high level qualifier. So here, when I wanted to use build command, or when I want to trigger the build process, whether I'm going to do the build of one program, that is, I'm going to compile the code change of one program, or I'm going to compile set of few programs, or I'm going to compile all the programs in your application, right? So for this, this is a building a single application. How do I use the build for one program? So the same 4 arguments, and I'm passing here the single program name. Okay, and so you can mention your program name here. And in case if I have a list of program, you can keep the list in the text file, and you can keep multiple programs which you wanted to compile here as you can pass as an argument. And if you wanted to build complete application, so here is your application name, and you can use as a full build. So full build command, it's going to take the complete compilation of your application, and it is get is invoked, and you can see the build results once this completes. You can also do the changes, whatever the changes happen, and because of the change there are some set of programs getting impacted. And if you wanted to do that, so we can go for impact build option. So this is going to take the files and programs since last successful bind. It is going to take up, and it will create the build results. So these are the 4 options we eventually will use for with the help of a DBB. So when we compile your build results is in such a way, you can able to see from the console window, your build will be, so we will be invoking your DBB user build from your IDZ, IBM Developer Fuzzy, and your console window will show us this results. So this is actually a result of your impact build. Impact build is selected for this particular application, and so whatever the recent changes, it is going to scan first with the help of the dependency scanner, and it will list down. See, it is saying that is whichever is undergone the changes, and it is going to update your collection under this master plans, and so eventually it is going to figure out whatever the uh, file names which is so found impacted. There was few file it has identified, and that it is adding to the build list. So it is keep on identify the changed programs, and it will write into see adding to the build list. So it is going to take it to list file.txt to build the build list. So there is a separate txt file. It is going to write whatever it is identified. It is adding up all your file names in list file.txt. Then this will be used for build command. So once you have this, your build process will make use of this. So build file is written on here, and this will get invoked by the build script. So build script, when you invoke, it is equivalent to our mainframe legacy approach. First, your uh, BMS map preprocessing happens, DP2 preprocessing, and then COBOL compilation, and then linked it. So that's a sequence in which the build script will get invoked. And once the build is done, your build results are kept in your build directories. So this is how it will add up, and whatever the build finds, it will write, and the build results you can able to see from your web application. From there, you have an option to look into the build results. Say, for example, whatever the sample application we have compiled, your build outputs are here, and whatever the build master changes, you can able to see it here. So this is your interface for your web UI for DBB. So DBB web application has two pages, home page and build page. Home page eventually have a little bit about your the users and what are the different collections it has got configured and those things. And the last build when we did, and you also have something called delete menu where in case if you are an admin, we can able to we will have a permission to look into the build results, and maybe if you wanted to clear up some build results, you can do that. And build results page is this is how it will look like, and you can able to get the detailed history and summary about your build results, and you can able to access via this link. If you get into this link, you also have can access the build report. You can just click and view, or if you wanted to download, you can download your build results, or you can also look into the build properties and logs, etc. All your complete detailed build summary or build detailed reports are available in the web application. So this is how your DBB supports your modern build process. So whenever you migrate an application from your legacy to the latest environment, so it may be anything like it's just some kind of a modern integration you're doing for IDZ and SEM. Let's say, for example, and you wanted to come out with an uh, DevOps pipeline, then DBB, we have to use it as a build tool. So this is how the build process works. And in here, we have seen the sample of COBOL CICS related applications. When you look at the real-time customer applications, it not only is going to have your COBOL or CICS or this vanilla language types, you do have various other language types, and which we can eventually look into how this what are the programs need to be invoked to compile and link it. Eventually we can do prepare our own Groovy script for customer specific application. Okay, and as a part of this webinar, we also do some complementary assessment. As I we also have some migration utilities, or you have seen the assets and uh, solutions, whatever we have. Our solution very well support your legacy SCM migration to modern environment with the help of our tool and this GBB customization. We can very much support the customer who are looking for the modernization, migration and modernization engagements with completely converting your legacy SCM to modern SCM and legacy build process to modern build process. So this is our complimentary assessment which we can provide you as a part of this webinar, which is absolutely free of cost. We can do the 3 weeks of assessment of your system, understand your system, and integration and customization approach, and we can come out with some kind of an assessment report for overall migration timeline and the implementation cost. You can feel free to reach to us at info@trisaber.com, or you can also call to us this number, and we can also do some kind of a discounted jumpstart as a part of this webinar, which is an 8 weeks of a pilot implementation which will support to migrate and modernize your build process with the help of choosing your pilot application, and which we can document and what are the various approach for migration and modernization of DBB build. So with that, let me open up a forum for Q&A. Uh, yeah, please feel free to discuss your questions. I'll keep the forum open for Q&A. Thank you so much for listening to me. And yeah, let us get into Q&A session. Thank you. Thank you so much.